Okay, welcome back, folks. Am I coming through loud and clear?
Clear.
Yep.
All right, good, good. All right, so to finish everything up today, this is what we're working on, and that finishes up the chapter. Tomorrow will be a work day in both in order to review, answer any kind of questions that you have to get prepared for the test on Thursday. I haven't decided. I don't think I'm going to do it on Arlock. I think what I'm going to do is make sure. I think there was only a couple of people that hadn't done the Arlock thing, so just make sure you know how to do it because we're going to need that for the midterm. Okay, I may just go ahead and do the Zoom test, but just make sure you know how to use that Arlock because the midterm is a very important exam, 25%, and it's got to be done through Arlock. That's the department's. Actually, the division wants us to do that. So that being said, let's see what else we can do to finish up this thing. All right, so 3 point, the third section that I break it into three sections is you've got some equivalences there. We already know about De Morgan's laws. De Morgan's laws are given right here. I just use them over there in that problem in 020 in order to write an equivalent or to write a negation. You can use it to do either one. But there's a few more equivalencies. Here's one. The conditional statement is equivalent to not P or Q. Not P or Q. The reason why we got the equivalence in a conditional statement that into a conjunction, I'm sorry, it's a disjunction, is so we can use De Morgan's laws to negate it. All right. So if we know that this is equivalent to a conditional statement, then if we want to negate, we can use De Morgan's law. So the negation of that whole thing right there means that we're going to apply De Morgan's law. And remember, it turns the sign upside down and then passes the negation on to the statements individually. If something is already negated, we'll negate it again. So here, the negation passes on, so it changes the or to an and. The negation passes on to the not P and the Q. Now the Q wasn't negated, so it just ends up being not Q, and then the not P is the P. So that right there is an equivalence. There's two of them here, and then this is the negation. All right, and you can see here from this truth table, they're equivalent because they're the exact same thing as far as the truth table is concerned.
One second.
I have them all. I have them summed up here, the two equivalencies that I talked about earlier. This is essentially the contrapositive. That's one equivalence. The other one over here is the one that just gave us there, right there. So that sums them up. These are De Morgan's laws, these first two. And then this is the negation right there of this one. Okay. So those right there can help you because if you don't have to do a truth table, you're going to be in a good position. So that's why these things can help us just know if something is equivalent. Okay. The variations of the conditional statement. All right. The conditional, if it starts out, it'll just start out as if P then Q. That's the conditional statement. So the second one, the converse, is where we just turn them around. And you can see it right here in the purple thing. This is the conditional statement. If P then Q. The converse is where we just turn them around, swap the antecedent and the consequent. The inverse is when we take the same order as the conditional statement and we just negate each statement. And the contrapositive is where we do both. We take the order of the converse and then negate each statement separately. Now, I have up here, this is that first equivalence right here. That's this right here, because these two are equivalent. So I'll just put that equal sign there to show. All right. These two are also equivalent, but I don't think you don't really need to use those, but they are equivalent to one another. But the conditional and its contrapositive are equivalent to one another. And as I kind of pointed out in that argument that we looked at in the end of the 020 class, the contrapositive is a valid form for an argument. And then here you can see the truth tables. See this? These two are exactly alike. TFTT, and the contrapositive is also TFTT. The converse and inverse, they're also, like I said, they're also equivalent to one another, but not to the other two, because the F changes position. It's in this third position. All right. Let's see if we can find something to work on here that I can show you. If you like this little one, this is kind of explaining how to do it. I jacked this from one of my fellow teachers. The only difference is that they use the terms hypothesis and conclusion, but it's the same thing. Antecedent, consequent, hypothesis, conclusion. But this tells you how it's done. In other words, you just exchange P and Q. The inverse is where you negate the conditional statements. For the conditional, you negate the P and the Q. And then the contrapositive is taking the converse and negating each one of the simple statements. All right, so let's look and see if we can write some of these out. Write the inverse, converse, inverse, and contrapositive of each. So I've already got P defined as dog is a Great Dane and dog is large. The conditional statement is if a dog if a dog is a Great Dane, then it's large. So the converse is where we just exchange P and Q. If the dog is large, then it is a Great Dane. Now, that doesn't necessarily have the same truth value as the conditional statement, because this one's saying if it's a Great Dane, then it's a large dog, because typically the Great Dane is seen as a large dog breed. But if the dog is large, There's a bunch of dogs out there that are large, like I had this friend that had like a golden doodle. That thing was huge. You could ride on it, like a that thing that they you see in the cartoons where they delivers the whiskey on your neck. That huge dog. I forgot what it's called, but there's all kinds of large dogs out there. So just because it's large doesn't mean it's a Great Dane. So see, that's why that truth value is different for those two. The inverse. We're going to turn them around. I'm sorry, we're not. We're going to take the conditional order here, and then we're going to just negate each one. If the dog is not a Great Dane, then it is not large. And believe it or not, that is an equivalent statement to the converse. So just because it's not a Great Dane doesn't mean it's not large. But those two things are logically equivalent. Now here's the one that's equivalent to the original conditional statement. It's the contrapositive called. If the dog, and I'm using the converse, and then order, and I'm negating them. If the dog is not large, then it is not a Great Dane. Okay? So that's the four different forms. The converse and the inverse, like I said, those are equivalent to one another, but so also, and more importantly, the original conditional statement, if the dog is a Great Dane, is logically equivalent to if the dog is not large, then it's not a Great Dane, which makes perfect sense because, you know, if it's not a large breed, then that takes out the whole category of large dogs, which includes Great Danes. All right, let's see. We'll do another one here. We'll probably do a couple of them. All right. So we've got this statement here, the original conditional statement. If there's no rain today, then the field is wet. Okay. Notice that that first statement is already negated. So when we negate, we're going to have to negate a negation. So just keep that in mind. We've already defined P as there is rain today, and Q is the field is wet. I always write the definitions of my statements in the positive form, and then I'll negate them when I write them out. If the dog, still thinking about dogs. If the field is is wet, then there is no rain today. So all I did was just turn them around. Just turn them around. Okay? That's all the converse is, just swapping the two. The inverse is where I'm going to take the same order and I'm going to negate each one. If the is no rain today, then the field is not wet. All right. Now I'm going to rewrite that so that we don't have the double negation. And then that's going to be if the is rain today, then the field is not wet. Okay, we're negating that negation on that first one. And then the contrapositive, we're going to take the first one, the converse, and then we're going to just negate. If the field is not wet, then there is no rain today. So that means it's, to simplify it, to take out the double negation, so there we got them. That's the 4 different forms. We can do it with any conditional statement, create those 4 different forms. All right. Let's do one more. I've already done them. Maybe I'll just talk you through them. All right. So here's the original statement. If there is not a chicken in the pot, then there will be no dinner. Now, that's really already written as with both negated. So we're going to have to negate negations on both sides. All right. But I still define my individual statements in the positive form. So P is there's a chicken in the pot. Q is there will be dinner. So the first one, and this is, I always generally go in this order because it makes the most logical sense. You're doing the least work. And like I said, because you do the converse first, it's the easier one because you just flip them around. And then when you get to the contrapositive, you can use that converse to negate, just like you do for the inverse. All right. So remember that the converse is if Q, then P. All right. So that means then this one right here gets turned around. So that if there is no dinner, we're just keeping that same order now. I mean, the same negation in there. Then there is not a chicken in the pot. I did not do anything to it except just turn it around. The inverse is where I negate in the same order. So that's not P. All right. So if there is not, okay, I'm taking this same one and I'm negating that negation, which is going to make it into affirmative. So instead of not chicken, if there's a chicken in the pot, then there is not dinner, which is then there is dinner. So there's your inverse. It turns out to be written with no negations in it just because both of the statements in the original conditional was negated. And in the contrapositive, is just taking the converse and negating. Okay. So let's look at that last one. We're going to then negate. So we're going to take that converse, and then we're going to negate the negation. So if there is no dinner, then there is not a chicken in the pot. So the negations take care of each other, take it out. So as if there is dinner, then there is chicken in the pot. Let's see here. See if there's something else I can do in here. There's one other thing I wanted to show you. All right. I'm just going to make one up here. But what I want to show you is this right here with a particular example. It's going to be using the same. It's not using the Morgan's law. I mean, I'm sorry, it's not using the four forms of the conditional. It's just using the ones that they gave us up here. Morgan's law, and then this new one. All right. So let me see if I can find this one here. All right, so let's put one here. All right. So let's say so we can't use De Morgan's law to negate it directly. We got to turn it into a disjunction first. So let's see. If we get an A, then we can have a party. All right. So A, so let's say P would be we got an A, Q, we have a party. All right. So we're going to use this one right here, which is also given up here. This is the summary of them. So I'm going to write the equivalent is we do not get an A, or Q, we have a party. All right. So we're following this form right here. The P gets negated. It was just a plain old conditional statement. If we get an A, then we can have a party. All right. That's like this. So the P gets negated. So we do not get an A, and then we replace the conditional sign with an or we have a party. Now, that is a logical equivalence of the original conditional statement. Now, to negate it, now we use De Morgan to negate. All right. And De Morgan's law, let's see, we're going to write this as we do not get an A, or we have a party. So let's do this. So that's not P, not P or Q. So I did this up there, but I didn't really go through it, just the theory. But now we're going to see again, we're using De Morgan's law just like we did here. This is an or, so it's closer to the second one. So we're negating that whole thing. The only problem is, see, that's already negated, so we got to negate a negation. So it's going to be not P and not Q, which is P and not Q. And so the statement would be, we get an A and we do not have a party. So a conditional statement can be negated by changing it to a disjunction and then using the disjunction negation, using the De Morgan's law there to find the negation of it. So this is the negation of the original statement here. You just have to convert it over to a disjunction before you negate it. All right. We don't have that much more to do, actually, so I'm trying to fill out the time, see what else I can show you. All right. So let's talk about the symbolic arguments. The symbolic argument is just the culmination of everything, very much like how in chapter 2, when we had the set operations, we were able to use that to do a survey problem. And so finding out whether an argument is valid or not is the same kind of procedure. It's just going to take into account everything we've looked at. You're going to have to translate statements into symbols, write your symbol. Your argument is a symbolic argument. And then right after you get that, you write it as a conditional statement symbolically and then do a truth table for it. Sometimes there's a shortcut. That's what this procedure right here is. But just remember, an argument is valid when the conclusions necessarily follow from the premises. It means that we have all T's in the truth table. We can also use a particular known forms and compare and so decide whether to reject it being as a fallacy or not based upon common forms. But the procedure right here for finding out whether a valid argument basically encompasses the whole chapter, because remember, the first thing that we do is we represented each simple statement in an argument. You know, in other words, what's P? P is we're going to dinner. Q is we're going to eat meatloaf, kind of thing. Then express the premises and the conclusion symbolically. All right, that's the symbolic. That's new, kind of, that form. I'll show you in a second. And then we got to write it as a conditional statement. An argument can always be written as a conditional statement. However many premises you have, those are what's on the left-hand side. You have the arrow because a conditional statement, an argument is going to be a conditional statement. So then the conclusion is what's on the right. Then once we got that, we can create a truth table for it, and that will tell us whether it's valid or not by the token of whether it has all T's or not. And that's the same thing as I get written up there. I'll just put that. All right, this is one of my favorites here because it deals with Star Trek and it deals with Mr. Spock. And I don't know if anybody's ever watched this. I never really was into Star Trek, but I remember one weekend they had like an all Star Trek weekend back when they used to do stuff like that on TV, and I watched a bunch of them in order to see the pattern and see what was funny about it. And anyway, Mr. Spock is an alien, and he's supposed to be very logical. Like he doesn't let human emotion interfere with his reasoning power. So everybody would go to him to kind of know what they should do. So this argument follows that. The only thing that's wrong with it and I can't figure this out, is they got Captain Cook in here. I thought it was supposed to be Captain Kirk. But anyway, I may redo it at one point and put the right captain in. I just know they made a movie, so I'm not 100% sure. And then they made several movies, and then they had several TV shows. So this may have come from one of those for all I know, and there was a Captain Cook for all I know. But it doesn't matter. The same principle applies. Is Mr. Spock got a valid argument here in what we got? So in Star Trek, the spaceship Enterprise is hit by an ion storm, causing the power to go out. Captain Cook wonders if Mr. Scott is aware of the problem. Now, Mr. Scott is the guy that runs the engines way back in the back of the plane. They can't see him. I'm sorry, back in the back of the ship. They can't see him. They can communicate with him by radio, but he's on the other end. Just like on any kind of a ship. You got the captain up top, and down at the bottom on a regular ship, you got the people that's running the engines, and you got one guy that's in charge of it. Now, Captain Cook wonders if Mr. Scott is aware of the problem. Mr. Spock replies, if Mr. Scott is still with us, the power should be on momentarily. Moments later, the ship's power comes back on. Now, believe it or not, this is an argument. Some of it's written, some of it's implied, because the light's coming back on is not a statement, but it does make up the rest of the argument. So the first part is the ship gets hit by an ion storm, power goes out. Captain Cook wonders if Mr. Scott is aware of the problem. Mr. Scott replies, if Mr. Scott is still with us, the power should be on momentarily. Moments later, the ship's power comes back on. So is this a valid argument? Well, first thing we want to do is write it in this kind of a form, just with the necessary stuff, with the statements that matter to this argument. So the gist of the argument is, if Mr. Scott is still with us, then the power will come on. The power comes on. That's the end of your premises. You got two premises. Therefore, Mr. Scott is still with us, is the conclusion. So the question is the argument valid or invalid? So first thing first, we got to go back to the very first part of the chapter. We got to define what P and Q are, the individual statements. There's only two statements in here. Mr. Scott is still with us, and the power comes on. So if we define those, then we can write this like as such. If Mr. Scott is still with us, then the power will come on. If P, then Q. The power comes on, so that's Q. That's the two premises. The line shows the end of the premises. The ... is code for therefore. And the conclusion is Mr. Scott is still with us. Here's the symbolic, right? It's symbolically, is a symbolic statement, a conditional statement. All right. Watch how we do this. If P, then Q is the first premise. We're putting an and between it. So you can kind of think, well, there's an and between these two. Always, however many premises you got to connect them with ands. Now, the Q is the second one. We draw the line, and then the therefore is P. So this is the symbolic argument. So then we're writing it as premise one, connect that together with the and the second premise is Q. Then we walling it all off because all of the premises stand on their own on the left-hand side of that arrow. That's what the nature of the argument is. The arrow means therefore, and then the P is the conclusion. All right. So let's go over and do this where we got a little bit of room. All right. All right. So what we're going to create the truth table for is if P then Q and Q, therefore P. It's only two statements, so not anything too terribly cumbersome. Only got 4 rows. So this would be the P. Here's the Q. So then it's just 2 truths, 2 falses, half truths, half falses on the first column always. No matter whether you got 2 or 3 statements. And then the second one is just true, false, going down. And that gets us all 4 of the possible permutations. All right. So what I'm going to put here is if P, then Q. Now remember, the conditional is the one that's order dependent. So with these, we've not done anything else. We don't have any negations, or we don't have anything like that. So it's really just going to be verbatim this one right here. Okay. So it's just verbatim this one, because everything is in the standard form right there. We haven't done any other work on it. So then this is going to be true. There's our naughty guy, the false one. The rest of them are true. We're just following that pattern here. All right. So now we're going to put together that one right there. And what are we putting together? We're putting together this one and that one when we're using and. That's always the last step before you do the conditional. The conditional is always the last one. This is the second last one, is where you put all of them together with an and. It's only 2 of them. So we're following the and. So we're only going to put a true in there if we got 2 truths. And you know what? There's 2 truths right off the bat. But as long as we got one F in there, it's false. The and does that. One F spoils it. But we got 2 T's there. So we got 2 of those. All right. The last thing. Now I'm going to rewrite the P over here because the conditional is order dependent. So I'm going to rewrite it again so I don't have to read backwards, because if I read backwards, then inevitably I'll goof up. So I'm just going to write TTFF here because the P is getting used again. All right. And the last step is going to be using the conditional. And we're using the conditional again on this third one. Let me write the whole thing out there. So this is for the whole thing. So now what we're using the conditional rule. We're essentially doing this one right there because we've already got this done. That's the left-hand side. The P's here. So we're always doing a rule on 2 rows. You got to handle them 2 at a time. So this is the final step. And remember, if we've got this pesky one where we got true false in there, it's going to be false, but otherwise it's true. So 2 true is true. False true is true. But oops, here's the false one there showing up. False, false is true. All right. So that's done. Is this argument valid? Well, let me write it slightly different. All right. So it's an invalid argument. 1F spoils it. All right. But it's always good to kind of have a different way of going about things to see if you can double check things, because doing a truth table is very tedious. And so if we make one little mistake, it helps to be able to know about it, to know whether we did something wrong. So what we've got are some things to help us. Here's the valid forms of arguments here. All right. That's all the ones that you're ever going to see in here, at least. All right. So here was our argument here. It was if P, then Q, Q, therefore P. Let's see if I can get these on the screen at the same time. Nope. It's not going to let me do it. But this one here, well, it's not one of these. See, it's not the law of detachment, because we had a Q here and then we had a P there. See, there's a Q, and these two are P's. This one is the one they call the direct argument or law of detachment. You got the 2 P's there for the Q, because essentially what it means is if P leads you to Q and you got P, then you also got Q. By the law of contraposition, by doing the not Q, then that can bring us to not P. That's a valid argument. These other two are less important, the law of syllogism. But basically what it amounts to is if P then Q, and then if Q then R, if these two match here, see if these two match, then you can just come straight across to P and R, and that gives you the valid argument. And then the disjunctive syllogism, they call it, P or Q, it'll be the first premise, and then not P. If we take P out of there, then we can state that we've got Q, because if P is gone, Q's all that's left. But here's our one that's going to help us answer the Spock argument. This right here I'm going to go up here and just put it right here so you can see. Take out some stuff so it'll come up and be on the same. So see, this is this one right here. If the green one and this one are the same one. It's a fallacy of the converse. And that also harkens back to what we were talking about when we were talking about the three forms of the conditional statement, that the original statement, the original conditional statement, and the contrapositive are equivalent, but it's not equivalent to the converse. The converse and the inverse are equivalent to one another, but they're not part of this valid argument. So in some cases, you can shorten things by not having to do a truth table, and that matches the result, because this is not valid because we got one F in there spoiling the broth. And also the fallacy of the converse, that it fits that form, so we know that's an invalid form. All right, let's see. We can do what else we can do. Let's do a couple more. All right, look at this one right here. We'll do another one with a truth table, but does that match up with any of the known forms up here? Remember, these are the valid argument forms.
The syllogism one?
Yeah, what happened? What happened? It took my stuff away. Oh, I'm doing the wrong darn back. Don't do this. There we go. Yeah, that's the law of syllogism, because notice it goes from P to Q in the first premise. The second Q is if P then R. Because these two match here, you got a nice path, so you could just take the shortcut and go across. If these two don't match, then it's not going to be a valid argument. But in this case, you're going from P to Q and then Q to R. So therefore, we could just take the shortcut from P to R. All right. So that's valid by the law of syllogism. Here, let me erase all this. What about this one here? Does that fit anything? That doesn't fit one. And they may not fit. So the only thing we can do is do a truth table. So let's do a truth table for it and see. Because I don't really know. I don't remember. I've done these, every semester, but I make sure. All right, so I'm gonna go take that one. I'm gonna go over here on this little board and put it in there. Let's see. Yeah, that's it. I thought I had named it. Well, for some reason everything is more than mighty slow all of a sudden. Is my voice coming through all right?
Yeah.
All right, let's see if I can put it over here. I don't know what's going on. There's something wrong with that board. Oh, that's the wrong one. That one came up awful quick, but that wasn't it. It's the other one. So this was it. All right. Okay. So the only thing to do is take it and do a truth table for it. So we got to go through the procedure of translating it into conditional statement first. So here's premise one. We're going to add it together. Then it was P and Q. Close off. And then it was P. So this is what we're going to create our truth table for.
So the
All right.
therefore symbol, like that's always gonna be conditional.
It's the arrow. It's the conditional, the arrow. Because remember, when we're talking about the conditional, this is the promise that if this is a valid argument, then this promise leads to this conclusion. This whole side over here is the antecedent, and that's the promise, also called the hypothesis or the antecedent. So that, if it's a valid argument, should lead to the conclusion here. But the only way we can tell is just drew a truth table for it if it doesn't fit one of the standard argument forms. All right, so let's go ahead and just draw that truth table. It's only two. All right, so here is our P, and there's our Q. So double, two trues, two falses, always this part. And then this one is just true, false, true, false. So then this is going to be the if P then Q, which is just the basic one. So true. There's the false one. And then we need the P and the Q. And that's just going to be the basic one. If there's two trues, it's true. Otherwise, it's false. So here, that's true. And the rest of them are false because they all have a false in it. And is very restrictive because you got to be in both. Let's put all of these together. Or put both of those together. So we're putting both of those together with the and again. The and always joins our parentheses, joins our premises. So and as long as we got two trues, we true. But in this case, all the rest of these are going to be false because they all have a false in it. And is very restrictive. And then the last is the whole thing. So the one thing that's important though is we're using the last step always in an argument is the arrow, because whatever you got to find out what this is. And on this side, you know what, I'm gonna bring the P over. Let me draw another line, because again, it's hard to read when you got to pass over several different columns and you're reading backwards. Because remember, the conditional is the one that's dependent upon order. So true, true, false, false. I'm just copying it from the first position. And this is the whole thing. The only thing we got to worry about is the arrow. But that's when we get this done, it'll represent that whole left-hand side. So arrow, true, true is true. False, true is true. Remember, the conditional is only false if we've got true, false. And in this case, there are none of those. So this argument is valid. Doesn't have a name that I know of.
Okay, so yeah, if I would have did the P first before the equation, it would have been wrong, right?
What do you mean?
So like you put the P behind the,
You mean here?
yeah. So if I would have
Well,
did
you
it in
could use
reverse,
this one. It's just that
I
you
gotta
got to
put that one
realize
first.
you got, yeah, the order is dependent. So you either got to read it backwards. All right. Look, you can do it. True, true is true.
Yeah.
False, true is true. False, false is true. And false,
Oh,
false is true. But you can't read it going left to right, because here the P is first. And then this one would be second. You got to
okay.
have it in this order.
Yeah.
All right. I was going to try to do another one. This might take a little bit too much time. We might save it for tomorrow. Let's see. This one should be all right. I'll do this one here, because I already got the P and the Q defined. So all T's means it's a valid argument. But sometimes you may get an argument in the while, so to speak. In other words, we got to know, we got to translate it symbolically first. So let's go over here and do that. So we've already got P and Q defined. The argument is I need to take a grad class in evidence gathering or civil rights. So that's like saying I need to take a class in evidence gathering or I need to take a class in civil rights. I couldn't get into the class on civil rights. Therefore, I'm taking a class in evidence gathering. All right. So let's write it out symbolically. So that's going to be so I need it's P or Q as the first premise. See, I need to take a class in evidence gathering, so that's P, or I need to take a class in civil rights, P or Q. I could into the class on civil rights, so that's not Q. And then the line and our conclusion. Let's see if I can make this thing as close as I can get to that on the keyboard. But that's the therefore. It's I think in reality it's called ergo, ERGO, which is Latin for therefore. But that's what that symbol means. And so I'm taking a class in evidence gathering, therefore P. All right. Do we need to do a truth table for this? Let me show you something. Oops. Let's go back to those valid argument forms. Here's somewhere. Almost. Here we go. So does that fit one of these?
Yeah, disjunctive syllogism.
It's the disjunctive syllogism. They do swap the P and the Q, but that's all right. As long as you're not swapping the negation sign, it works. Because you see down here on the fallacy of the fallacy that looks very much like this one. They swap the negative sign, but that doesn't work because what the negative sign does, or the negation sign does on that second premise, is it rules one of them out when you got an or. If you've got P or Q and you take P out, then you conclude that Q. But you can't do it the other way around. If you've got P or Q and you say P, well, that does not lead to not Q.
Are we
So
gonna have to
this,
memorize these? Should we
pretty
memorize?
much,
Okay.
they will help you not have to do the truth table. So that's why I'm saying that there's only those four essentially, and these three. For the most part, you're probably not going to use all of them. So when you're going through the review, see. So therefore, this is a valid argument because it fits the form of the disjunctive. All right. So that's pretty much sums up the whole chapter. So tomorrow we can review. So try to work on that review. I think you should be able to access it. Let me just double check. And if you got any questions, you can stick around. But let me just double check and see if it's open. I'm pretty sure it opened today, but I like to test it.
Is the review under assignments?
Mm-hmm. Let's see. Yeah, you got the 1, 2, 3, 4, 5, the 6 that are left, the assignments, and then the next one is says test 2 review. Test 2 review. And I was just going to click on it. I think it opened up at midnight. I just want to double check. So when you go through there, you can let me know tomorrow if there's any that are fishy. You know, like I said, there was one that was graded wrong, and then there was that one like I took out with I don't think you need to know about geography or anything. And then I took out a couple of more that I felt like were repeated. So you can let me go. So yeah, it's ready to go. You got 5 attempts on it. There's 30 problems in it, and like I said, is just let me know if you see any that are screwy. Okay. So otherwise, I'll see you tomorrow for review. Bring your questions to the 020. All right.
Thank you. Have a good day.
Thank you.
Okay. Stick around if you got questions.
Thank you. Have a good one.
All right. Bye bye.
Bye bye.